So, what about this Geiger counter which is now sitting in the case? Well, let's first contrast it to a few other examples. This unit is a dosimeter which unfortunately has now died, has problems with its detector diodes. It isn't technically a Geiger counter because it uses photodiodes to detect radioactive particles. I do need to look into repairing this. This is a British survey meter from the early 80s, sort of mid-80s. The PDRM 82 made by Plessey. This is the sort of unit you'd want if a nuke was dropped outside, or maybe it might pick something up after a reactor meltdown. If I ever go to Chernobyl, I shall surely take this beast along with me. The other unit in the series is this little beastie. Tiny little thing. Once again a dosimeter, simple operation, detects standard background radiation, much like this. And this one is just a standard sort of clicky click background radiation job. This one is unique because this one detects not only just background radiation, but it also detects high level radiation thanks to a rather inventive free tube design. And it comes in this lovely old box that is battered from years of use and storage, and because of its origins of being I believe a Polish unit, maybe Russian, this might have seen use back in Chernobyl. So we open it up here and we have this lovely manual written in a language we cannot understand, but this is the DP-66 and a Ranten radiometer. In other words, that's essentially its native language for Geiger counter. There's little bits like that you can sort of work out through logical deduction, but the real thing that is of real interest in this particular manual is a full schematic. We're going to a closer look at this later in the video because we won't actually be tearing down the unit because it's fully sealed, and I kind of only want to crack it open when I have to, basically. It's 40 odd years old and I think the seal should be left intact until it breaks and needs to be repaired. However, I can show you inside the probe. This is an extender unit that you would use for attaching the probe to here and holding it up here, so you can scan the ground while walking along, essentially looking for contamination, say in the event of a reactor meltdown, Chernobyl, even Fukushima. We have the main unit itself here, held in a lovely leather case. We have two neck straps, which are all of this is in surprisingly good condition. Yeah, the metals are rick-rolled and things like this sponge sort of long finished. We have a few specifications up here in this 1972. Sorry, jump cut. Yes, as I was saying, on this side we have these nice slidey out panels, and in here we have a mains PSU, which is European style, complete with probably absolutely no safety whatsoever. It's actually dirt simple inside this thing. And on the other side we have bags, so you can use your probe in environments where it runs the risk of getting contaminated, and well, a radioactive Geiger counter is not very much used because then it will only detect itself. And of course, the little piezoelectric headphone, complete with a little 2-pin plug. This is a bit worn out, I need to build my own solution. And the unit itself is stored in this case. Now unfortunately the test source would have been here and has been unfortunately removed, which is a beta source. Here we have the front fascia, we have the selection switch. This is your range selection switch, complete with battery test mode. Battery's still full. You have a backlight switch, which you might notice the backlight turning on and off. You have a meter centering switch, and two mysterious ones. A mysterious knob, which I do not have a clue what it does, and a mysterious screw cap, which looks like a place where it's sticking an external probe or even some sort of subject to be tested. But I have no clue what these two items are for. As the manual is written in a language I don't understand, in a with an alphabet I don't understand, there's no chance of me deciphering what they do, because they don't seem to change anything in operational functionality of the Geiger counter. When we get to this panel, we get to the point where the actual probe is stored. Well, for a very clever configuration, you can see this can also be extended, so you could attach it to the bar here. The probe is not actually detachable from the Geiger counter. We have a belt clip, nice rubberized handle, which is more sort of a plastic handle these days. Spring to sort of reduce wear. You've got your beta selection. You've got a beta times 10, which is just a small hole, and gamma, so this is aluminium, and as you can see there's a fair bit of corrosion on it. I always leave it on the beta personally. When we pull the unit out the leather case, which is a bit awkward because it's a nice tight fit, it's actually a surprisingly small unit for what it is. At the back there isn't really much, there's a screw hole. Here we have a wax seal over the screw. I want to keep that intact authenticity. I got a schematic, so I don't need to crack it open. And of course, your battery slot, which is really tightly done up. And of course where your headphone goes in. And this takes 2 D batteries. These can be quite expensive depending on where you get them. So that's given me an opportunity to actually see if the batteries are still good and haven't leaked everywhere. So, while we're busy screwing this on, one interesting fact about this is not just the fact that it's a 3-tube design, but also that it's fully transistorized. Now this is relatively surprising, bearing in mind the date code of 7126 and 1970 on this. The case is made entirely of Bakelite rather than plastic. Instead they're using an early plastic substitute. Like you get old phones made out of this stuff, and you can sort of see the forming process of the swirls from where they mixed in the colour, but didn't quite mix it up evenly, given this rather beautiful patterning. It takes your standard slot screws, 2 points. Someone's had a go at trying to get into this at one point, and in fact that is actually loose to the point you could pull it out without damaging the cap. I wonder if the other one's like that, which means that this might have actually been opened up in the past. And the other bit of interest is the probe. We'll get round to this when I download the data off the camera. As we do. So the next point of interest is the probe. So to get it open for various maintenance and easy replacement of potentially damaged tubes, the designers of this were quite sensible and made it easily operatable by the user in the field. You unscrew this lovely, rather than quite nice mechanism under the O-ring, pull the top off, There's inside the top, which is just a black chasm to you lot. And here we have the 3-tube design complete with a transistor. Now what we have here is seems to be a popular Russian Geiger Müller tube. This is used in a variety of Geiger counter designs, complete with positive marking. And you'll find similar variants used all over the place and on eBay. And what it is it's basically a gamma and beta probe, as most of these are. The next one will probably fit in for the mid-level of the radiation. And the last one there would be your high level, for your absolutely insane nuclear fallout levels. And as you can see, there's a whole bunch of resistors which are either used to increase the impedance. There's one thing with Geiger Müller tubes is they are very high impedance devices. It doesn't take much to cause a false trigger, a little bit of electrical noise. If you open and take this off when it's on and put it back on, you actually get a massive spree of clicks because of the static electricity produced just by moving this. And it causes a load of false clicks. Here we also have a transistor. Obviously we are unable to read its markings, but it looks like, but they have silk screened it with the silk screen of the PCB. We also have over here an L1 and an L2 referring to potential inductors, which are not actually visible on the board. Maybe they were never used. We have a 10 UF 250 volt capacitor, so we're looking somewhere about 200 volts to drive these tubes, or at least one of them, and so on. The types they are a bit hard to read, but that looks like a DOB5 something. That looks like a Russian letter on there, it could be a 5-4. That one is a B80, and this one has a CTC5 something. I'm not actually taking these out, their holders. Although removing this one, because both points of the tube going at either end would be a bit difficult, getting these two out wouldn't be such a challenge. So, let's move on to the schematic. A few points about the physical design that must be noted. Note this PCB riveted onto the end here just to hold its centre in the actual case, as well as bolted at the end here, but you'll also notice it's all soldered in, so it's not fully serviceable in the field, only partially. But most of the electronics aren't here. This transistor would probably be used as a pre-stage amplifier, because when you think about it, the signal's got to travel all the way back through this wire. Yeah, could be potentially noisy, loss. So you probably want to use a preamp in there somewhere, which is probably what that resistor's about. Then they're part of the inductance circuit. They don't look like they're a voltage multiplier, although there probably is one in the circuit somewhere. As a matter of reference, I would like to show off this particular diagram. Perhaps someone can help identify the mysterious knob and connector, which is 4 and 5, and be ever so kind to convert what this list actually says. That'd be much appreciated if someone could do that, because I lack the ability. I don't really know anyone who could as well. Yep, I'm in university. I knew someone who was from Russian origin, roughly about there, but they didn't seem to know that region of the world. So yeah, anyone got a clue? Put it in the comments. Surely someone from the Russian or Polish region has got to see this video. And here we have the schematic. If we zoom out a bit, but not too much, you'll notice that all 3 tubes on their output going to the transistor are essentially a preamp stage. You've also got the resistors aren't quite shown in circuit, so obviously not all of them And you've also got the resistors in circuit as part of the impedance. That's in correction. Another interesting thing to note is over here they give you a key of what the transistors are. The three main types they use, I think. And then as we go back, we go through the various amplification stages. We've got the meter here. Somewhere we should have our selection switch on here. Let me just look at it and identify which it is. Because we've got several points here, here and here which could comply with the switch, the multi-point switch. We also got a whole load of adjustment trim pots. Here is our main step-up transformer with, of course, the battery pretty much just drives a step-up circuit. You've also got I think this is for the power supply in the case, and you've got that. You've got the light bulb with its own switch. It's connected parallel across the battery, hence we're able to switch it on like this when the device isn't even on. Here we have the multi-vibrator circuit, which would essentially give the AC forms for the transformer to step up. We've got what is the, I think that's the piezoelectric element, another light bulb. Another light bulb, huh? Maybe we'll have to crack this thing open after all. Whole load of capacitors. Most of this is going to be various forms of amplification equipment, because I've actually built one and it pretty much consisted of generate high voltage, create a high impedance point between the tube and the amplifier input. I believe, if I remember correctly, that's an LM386. This is all transistor. And you can get away, because the voltage spikes can be quite large, with linking things like neons directly across the point, as well as meters, which, as you can see here, has a little bit of extra circuitry, but not much. Oh, has a bit of extra circuitry, but not much linked to it. It's all quite nice. I wish modern user manuals came with schematics of the product you have brought, but they don't. We do have a few unknown looking things like that symbol there, but even though the origin of the actual unit is not actually made in an area that speaks my language, at least these circuit symbols are universal. So you could, following this lovely guide, essentially build your own electrically compatible machine. Hence I'm giving you a nice slow pan if you decide to actually embark on doing that, giving you the full schematic. And if you do make one, send me a line. I'll quite be interested to see what you made out of it. But it doesn't individually select the tubes. Well, it does, but not in the way you'd expect. Maybe it does, but yeah, the tubes are selected from the negative end rather than the positive. Makes sense. Positive is where the signal go. Too much chance of sending noise across. But there isn't much else to say. I'm going to have a go and see if I can pop the back off this. Well, see if those seals are broken, and then might as well pop the back off and have a look. The answer is yes. One was already loose on one. The other seal is pretty intact, so I won't worry too much about it. Although we could get this open, because these are essentially things. We could do it with a set of pliers. I think you can see what I'm thinking. So internally this is quite an interesting array of really vintage electronics. Here's your battery tube, your lovely moulded Bakelite case. Turned out it wasn't hard to defeat the see the tamper detection without being detectable. And of course, if we look here, we have a board which is covered in wonderfulness, and including some nice, really vintage diodes. There's the transformer, the big round cylindrical thing, meter there, and interestingly, the hole goes into that second light bulb we saw on the schematic. And there's another switch for it. Fascinating. What happens when we press it when it's off? Absolutely nothing. We'll have to open it up and have a look. So this might be something to do with sample analysis. Who knows? You pop it in the hole, you press the button, it lights up, shines through, and I don't know. That's a pure guess. 630 volts on that capacitor. But yeah, rather interesting bit of kit. Multi-stage tactile switch. Jump cut, blame the camera. So, as you can see, it's rather quite interesting inside. It's quite complex. You've got the lovely military bundled up wire. You've got all the lovely characteristic military stuff. You don't have conformal coating, but then this is from the age before conformal coating. And of course, everything here is going to be high value. You know, precision capacitors. 680 PF, 2%. How many 2% capacitors do you see elsewhere? Not very common. But let's put this together and try and measure something radioactive. Did I also forget to mention it also has a luminous face? Which is not the radioactive kind. We are still unable to identify this. What is the purpose? Why does it have a light bulb at the bottom of it? Where's the mysterious switch that's supposed to switch it on? And why is it in the headphone circuit? You'll also be able to hear it clicking because this camera's got such a terrible microphone. I've basically got the headphone pressed up right against the microphone of the camera, so it should be picking up the clicks, as well as you can see the needle. Now there comes into one problem with measuring radioactive items of this, with me in general, is in amongst my various collections, I have absolutely nothing which is radioactive. The only collection I have been unable to test to date is my gemstones collection, which consists of things like quartz, amethyst, that kind of stuff, and it's all in the loft and I don't know where it is, because otherwise I'll pull it out and test it all. But I've measured rocks around the garden. I cannot find anything that really goes above background radiation. However, I have taken this a few places with me and found that university, for example, has a higher background radiation than here. I also took it to the science labs in the university, because I'm at the University of Greenwich, but in the Medway campus. Well, that's where I spent the 3 years doing the undergrad. Now I'm doing a master's there in computer network security. I was able to go to the science department and have all my units tested with the radioactive materials they do have in the science department. Sadly, there were none they could give me, unfortunately. So, despite having a small collection of Geiger counters, I have no sources I can test them with. The only thing I know that has a radioactive source in is this. It has a little beta in the actual Geiger tube itself, but it's shielded to only detect gamma. So basically, I can't even detect the source in this. I have tried. But that puts our conclusion to the video, looking at the DP-66 Geiger counter from either Polish or Russian origin. It is unknown which, and we even got an unexpected teardown bonus. Thanks for watching. I hope you enjoyed, and I also hope you can also bring back more information about this unit. Oh yeah, extra note. Unscrew this to adjust the position of the needle. And of course the O-rings, and that would make it waterproof, although I wouldn't try throwing it in a bath these days, bearing in mind it's 40 years old and that rubber is going to have perished and turned to plastic. Thanks for watching, hope you enjoyed, and I hope you can also put some more information and relevant information in the comments. This is not an uncommon unit, you can find videos of it over the internet, mostly in the sort of Russian regions though. Thanks for watching.